This windmill stands in the Rhenish Open Air Museum in Kommern. When it received a new set of sails, the Millwrights' work was captured on film. The foresails are attached to two massive oak beams. On the mill roof, the cap, the stocks are inserted crosswise into the windshaft head. A massive beam structure at the back of the mill allows the cap and sails to be turned into the wind. The power of the wind is transmitted through the shaft into the interior of the mill. This is the same windmill before the set of sails is attached. The windshaft head on the mill roof is ready to receive the two stocks. The stocks must be pulled into these two openings of the windshaft head. The first stock lies on the ground where the millwright and assistants attach the end of a pulley system. A block and tackle and a hand-operated ground winch take over the function of a modern crane. With these simple tools, the stocks will be pulled up to the mill roof. Now the men assemble the ground winch, which they will use to haul in the pulley's rope. The ground winch consists of a wooden frame and a matching axle piece. During preparation, a rope is also attached, allowing the beam to be aligned while being hoisted. Two strong wooden poles serve to transfer muscle power to the ground winch. The men begin hoisting the first stock. A guide pulley directs the pulling rope in the desired direction. As the assistants constantly turn the winch, the stock slowly lifts off the ground. The load to be lifted hangs from the lower loose pulley of the block and tackle. Using the ground winch, the men gradually haul in the pulling rope. With the rope attached during preparations, the stock can be held in the correct position. Finally, the tip of the stock has reached the windshaft head. Here, the millwright levers it into the opening of the shaft head. When the tip of the breastpiece protrudes slightly beyond the shaft head opening, the millwright must temporarily secure the beam. He uses an iron rod for this, which he inserts through a hole in the tip of the breastpiece. This is necessary because the pulley block has shortened so much that it must be pulled apart again. For this purpose, the assistant now detaches the pulley block from the middle of the beam and reattaches it to its lower end. As the ground winch continues to turn, the breastpiece is pushed into the shaft head. The millwright's assistant connects the chain to the pulley of the cable pull. Now the men can operate the ground winch again until the breastpiece protrudes a bit further from the axle head hole. Then the millwright hammers in the pin, which will later serve to secure the sails. Slowly, the breastpiece beam slides through the box-like guide in the axle head. Finally, the breastpiece has reached its final position. Now the millwright must wedge it firmly in place. The millwright hammers in the wooden wedges on only two sides. On the other two sides, the breastpiece must lie flush against the opening of the shaft head, as can be seen here on the left side from the cap window. To hammer in the wedges on the side of the shaft head now facing downwards, the millwright has the breastpiece rotated 90 degrees. The oak beam is thus secured with wedges on both sides at the same point. The front opening of the shaft head, intended for the second breastpiece, is clearly visible here. The second breastpiece lies ready on the ground. The sails are attached to it for a trial fit. Each sail consists of a narrow leading edge with continuous board cladding and the wide trailing edge, which looks like a ladder due to its rung-like wooden slats. The connecting piece between the leading and trailing edges is the stock. To mount them on the mill, the pair of sails must be taken apart. First, the men remove the windboards from the leading edge. Iron bands hold the pole and the sail together. In the image, the narrow leading edge and the wide trailing edge of each sail can be seen. Once the men have loosened the iron bands, they can carefully lift off the sails. The pole is made of oak, a particularly sturdy and durable type of wood. In total, it is 14 meters long. With a chisel, the assistants remove the pin from the pole beam. Then they attach the lower pulley of the block and tackle to it. Using the ground winch, the men pull in the rope of the block and tackle, which is attached with the movable pulley to the load and with the fixed pulley to the mill shaft. Slowly, the pole lifts off the ground. By turning the ground winch, the entire rope pull shortens and the load is raised. Another millwright directs the work from the ground. After further turning, the beam already extends beyond the shaft head and is secured again with the iron rod to prevent it from slipping back. The block and tackle has become too short. The assistant reattaches it to the lower end of the beam. After further hoisting, the millwright hammers in the pin. Then he brings the pole into the correct position for wedging. The pole is wedged again on two sides of the axle head. Then, from the ground, the mill's brake is released to rotate the beam into a horizontal position. This mill comes from Lower Saxony and is a so-called octagonal mill. It is considered a predecessor of the stone tower windmill, which was built in the Rhineland, especially in the 19th century. As soon as the front breastpiece is horizontal, the mill builder can drive in more wooden wedges. To build a mill, the mill builder had to master a wide variety of craft techniques. For this reason, the mill building apprentices learned the wheelwright, turner, and carpentry trades during a 5-year apprenticeship. When the two breast pieces are firmly wedged in the shaft head, the two pairs of sails can be attached to the breast pieces one after the other. Each sail is not made in one plane, but slightly curved. The measurement by which the curve in the sail was calculated was the secret of every mill builder. The sails are also pulled up with the help of the ground winch and the block and tackle. Only 2 men are needed at the ground winch for this. The sails must be stable but light. Usually the mill builder used pine or spruce wood. Pitch, pine and larch could also be used in sail construction. The sail cross on the shaft head catches the movement of the wind. The mill shaft or axle then transfers the power to a system of gears inside the mill. In this way, one or more grinding units inside the mill receive their driving power. The sail has reached its seat on the breastpiece. Now the mill builder's assistant can connect the breastpiece and sail together. On the ground, helpers prevent the sail from slipping. The three men ensure that the upper end of the sail lies exactly against the shaft head. Once seated correctly, the rest of the sail must be brought into the tholes to lock in. Then the millwright's assistant connects the sail and the breastpiece with iron bands. It's clearly visible here how the sail rests on the breastpiece. Each sail is firmly mounted to the breastpiece with 2 bands each. The iron bands lie on the ground, ready for assembly. The tholes and iron bands provide a stable connection between the breastpiece and the sail. The first sail is attached to the breastpiece. The mill shaft is turned further to receive the second sail. The ground winch is also used for this purpose. The sails are carefully attached in reverse order to the mast. The men carry the counterpart to the first sail up to the mill hill. This mill originally stood in Cantrup, a place near Osnabrück. It is one of the few buildings in the Rhenish Open-Air Museum that does not originate from the Rhineland. The Rhenish windmills are all under heritage protection and may not be demolished. After the Second World War, the Cantrup mill was hardly used anymore, as wind operation was no longer profitable. In 1969 it was dismantled and 2 years later rebuilt in the Rhenish Open-Air Museum. In the meantime, the second sail has also been pulled up. Now it must lock firmly into the tholes. The breastpiece and sail are connected to each other with iron bands. The pair of sails now mounted in the outer axle head hole is called field rods. With the help of the ground winch, the mill shaft is turned further to attach the sails to the inner axle head hole. These are referred to as house rods. Before attaching the house rods, the men take a break. Then the next sail must be hoisted up. The craft of the millwrights, also known as mill doctors, was an itinerant trade. Often the millwrights wouldn't return home for several weeks, as their clients lived far apart and in remote areas. Major tasks, such as building a roof or a sail cross, were not done in their home workshops, but directly on-site at the mill. All but one of the sails have been fully mounted. On each sail, you can clearly see the narrow leading edge and the wide trailing edge. In total, a sail is approximately 12 meters long and 2 meters wide. The sail cross is one of the most delicate parts of the windmill. This is where the most frequent and costly repairs occur. Storms and thunderstorms in particular can shorten the lifespan of a sail. Therefore, the millers always watch the weather very closely to take the wind out of the sails in time. The final sail is being hoisted up. As seen in the foreground, the tip of the sail has a slight tilt known as the top. Without the top, the sail doesn't utilize the wind power effectively. In mill terminology, such sails are said to let the wind shoot through. It takes the men a total of 2 days to fully assemble the sail cross. Good wooden sails have a lifespan of 10 to 15 years. The Kommern Windmill has a modern cast-iron shaft head instead of a wooden one. The number 1903 on the axle head indicates the year it was manufactured. However, the mill itself is older. Wooden slats are ready on the ground, which will be used to make the sails fully operational. This mill features so-called shutter sails. Unlike common sails, which the miller covers with canvas for grinding, shutter sails consist of movable wooden flaps. The men must screw the flaps tightly onto both sides of the trailing edge. The individual flaps are made of wood and are mounted to a pull rod, which is a long wooden lath. Because each individual slat is connected to the pull rod, the shutters can be opened and closed. Another shutter slat is handed up to the millwright and his assistant. First, the men fit it into the rear frame. Then the assistant screws the slats joint to the pull rod. Meanwhile, the millwright inserts the shutter between the outer strut of the rear frame and an extra lath, which he then screws tight. The pull rod leads through another joint at the shaft head into the interior of the mill. In this way, the miller can easily regulate the surface area exposed to the wind from inside the mill. This sail system became widely used in Germany from around 1900. It is one of a series of inventions made by millwrights and engineers in the 19th and 20th centuries to better utilize the wind. Ultimately, however, wind power could not compete with the new energy sources of the industrial age. Steam engines and later electric and diesel motors have replaced wind and water power since the 19th century. By the end of the Second World War at the latest, most Rhenish windmillers had given up their milling operations. As a result, the millwrights also lost their livelihood. The few millwrights who master the old techniques restore the remaining mills, which are now protected as historic monuments. The shutter slats have now been fitted to all 4 sails. Using a chain, the millwright releases the mill's brake. In a final step, he checks the correct balance of the sail cross. The sails turn easily and evenly. For now, the millwright's work is finished.